Hello everyone, welcome back to the last lecture of the third week of the MOOCs course on Advanced Analytical Technique. I am Dr. Mohammad Zain Khan, working as Assistant Professor in the Department of Industrial Chemistry, AMU Aligarh. Today, I am going to discuss about the advantages and disadvantages of ICP AES and few spectra I am going to show you to give you an idea about how we make the analysis. Let us begin this lecture. The advantages of ICP, yes, of course, since we go for multiple element analysis, so I can say that it is a very rapid analysis which gives quick results, because even in a single run, if we are using a polychromator device that we have discussed in the previous few lectures, which uses a Rowland circle, and we have multiple exit slits followed by PMTs, different PMTs, and we have concave diffraction grating over here, we can capture different light radiations, and in a single run we can do multiple element analysis. On the other hand, in the second case, we use an HL grating that helps us to create individual very narrow wavelengths, and those wavelength passes through a plate aperture, and finally we use a solid state array detector which is based on charge coupled device, so we can go for up to 50 to 60 elements analysis in a single run. And therefore I can say that since we can go for simultaneous analysis, this techniques is very quick, and since we can achieve very high temperature up to 5000 or even 10,000 Kelvin, even all the metals, all even high melting metals, refractory metals can be analyzed by this technique. This technique is very sensitive, so even low sample or sample in which we have very low amount of elements like precious metal sample of gold and platinum, or even blood sample which are having very low concentration in case of a person is having some sort of poisoning, so that low sample or the small volume of the blood sample can be used because of the high sensitivity of this technique. Further, the limit of detection is very good. We can go up to 1 nanogram per liter, and we can go to as high as 100 nanogram per liter. So the range is very good. Even higher as well as low concentrations can be analyzed by this technique. And further, the technique is very accurate and precise. Precision means the results are reproducible. If we are doing repetitive runs for a single sample, the results obtained in all individual runs are very close to each other. If the values of the concentration of sample determined in different run, but those values belongs to the same sample, these values are very close to each other, then I can say that our results are having very high precision. And accuracy means how close the experimental or the calculated value to the true value. So the machine is very accurate, the calculated or the determined value which is determined experimentally is very close to the true value, and if it is also having very high precision, if we are doing repeated runs, the results will be almost similar in all the cases. Then of course, each and every technique has its pros and cons. Is this technique as well, it has certain disadvantage. The first disadvantage is, of course, we all aware of, because since it is a high since it requires very high temperature, we are using plasma, we are using quartz tubes, we are using radio frequency that can be used for multiple element analysis. We are also using solid state array detectors, so all these things make the equipment very expensive, so it causes the cost to go up. Sometimes we have too much spectral lines, which makes the spectra very complicated. We may have different lines. Some of the lines are very close to each other, and therefore it makes the analysis quite complicated. Further, due to very high sensitivity, peaks from the previous runs are also detected. So every time we have to flush out it with pure solvents. We may not have excessive peak from the previous run, and since a plasma is to be formed and very high temperature is being achieved in this particular technique, so a highly trained person is required to operate the machine. We cannot allow anybody with no experience of this machine to go and analyze this machine, because there are hazards as well, and because of high temperature, the person may get hurt. Further, the machine is very expensive and delicate, so we never allow someone who is not properly trained to work on this particular machine. These are the application of ICP. It is used for the analysis of trace metal in alloys. So it can, so in case of alloys, we can identify the different elements present in it. We can establish the composition of the alloy, and for that we digest the sample by using dry method or the acid digestion method. Then we go for water quality analysis of river and groundwater sample. In these two cases, river and groundwater, we do not use any excessive sample preparation method. We just filter the sample and we can go for the analysis. Then presence of lanthanides and other elements in the rock sample can also be analyzed, especially useful for people from geology background or geographical background. And in this sample, even the rock can be digested by either the alkali fusion method or the acid digestion method. Then finally, we have even presence of metals in lubricating oil or in gasoline. You might be aware that in gasoline, various countries are still using tetraethyl lead compound. So the presence of lead, although it is banned in India now, but still we can go and ensure that it is completely free from lead or not. For that, we can take gasoline sample and filter it, and we can, if the viscosity is, although the gasoline viscosity is not high, we can use it directly. For lubricating oils, they are highly viscous, they have very high viscosity, so we can dilute these uh, lubricating oils to control their viscosity, to minimize their viscosity by using some solvent, and then we filter it, and then finally we can analyze it by injecting into the nebulizer, so that presence of metals in that lubricating oil can be properly identified. Then determination of aluminium in blood, even copper can be determined in the brain tissues. For brain tissue analysis, we have to digest the sample and filter it, then finally we can inject it into the nebulizer for analysis. Even selenium in the liver can also be detected by this particular technique. Finally, determination of trace element in polymers. So polymer can be analyzed to identify what kind of elements are present in it. In even serum sample like blood sample can be analyzed, where calcium, copper, iron and Mn can be detected. Serum basically used for blood samples, the blood in which the plasma part of the blood, which is free from RBCs and platelets, is basically called as serum. From the plasma, when we remove the clotting agents like the fibrinogen protein, the plasma is called a serum. So clotting agent, so clotting agent free means the plasma without clotting agent, plasma is called as serum, and plasma means already we have removed the RBC and platelets as well. So even serum sample can be analyzed for the possibility of calcium, copper, iron, Mn and other elements. So these are some of the applications of ICP techniques which make this technique very versatile, because you can see here we can go for serum sample, we can use water sample, even we can go for metals and alloys directly, we can also use rock sample, even highly viscous lubricating oils can be used, even biological samples like liver, tissue and blood can be analyzed by this technique, making it highly versatile and widely used technique across the globe. In the next slide, I am going to share a spectrum of ICP AES. So in the next few slides, I am going to show you some spectrum. Look at this spectra. This is an AES spectrum, atomic absorption spectrum, which can be used for few elements, around 50 to 55 elements of the periodic table. Here you can see we have analyzed a sample in which iron, tin and cadmium are present, and you can see the beautiful spectrum where all these peaks are quite isolated and very easily resolved from each other. The height of these peaks shows that this blue color, which corresponds to cadmium is having the highest percentage, followed by iron, and then tin is present in the lowest amount. And further, on the basis of their wavelength at which they are coming, this shows that it is at 228.8, while this is coming at around 227 to 228 228.7 or 228.7, while it is coming from 228.70 to 228.75. The wavelength is lower this side. This means higher energy. So this particular spectra absorbs higher energy, while this spectra of iron absorb moderate energy, and finally cadmium. In case of cadmium, the energy required for this particular absorption was lowest among the three. So while analyzing these spectra, we first of all identify the wavelength on the x-axis, at which wavelength they are coming, and then these wavelengths are compared with the standard sample. We have literature available in which the characteristic wavelength of all the elements is given. We match our spectral lines with the wavelength given the spectrum, or sometimes if it is not available in the literature, we go for a standard run. We bought a pure sample, we go for a standard run, and then we compare if it is coming, if it is matching with the standard, then we can say that it belongs to that particular standard. Further, the height or the peak area can be used for concentration. So concentration or the quantitative analysis is done by peak area or peak height, while the position of the peak on the x-axis, means the wavelength, is used to identify the type of sample. So in the previous case, since the peaks are quite away from each other, so there is no overlap and there is no complication in the analysis of the spectrum. This is an AES spectrum. Now you can see, while in the previous case where AES I have shown you SN, Fe and CD only, in this particular case you can see that even oxygen can be detected. As I told you that certain non-metals like carbon, sulfur, nitrogen, oxygen can be detected by atomic emission spectroscopy. So you can see the peaks of OH, N2 and the metals Mg. We can have An, and we also have hydrogen peaks. We have peaks of hydrogen that can also be detected with atomic emission spectroscopy. There are two peaks, H alpha and H beta. These H alpha and H beta lines are present in the hydrogen spectrum of Balmer series. This alpha belongs to red color and this H beta belongs to blue green color. These red color H alpha lines are formed when electron returns back from third level to second level, because in Balmer series the hydrogen spectrum, it is formed when electrons from higher energy state comes to the second energy state. So when they come from N3 to N2, red lines are emitted, H alpha, they are called as H alpha. When electrons coming from N4 to N2, blue or green lines are emitted, they are called as H beta. So in this particular spectrum you can see even metals and non-metals can also be detected, this potassium metal. So this is an AES. This is not possible with AAS. Here you can see we have spectrum, we have characteristic spectrums of OH. So O can be detected, hydrogen can be detected, even for nitrogen. So this technique is used for metals as well as non-metals, certain non-metals and metalloids as well. AES, not possible with AAS. This we have already discussed. These are the two hydrogen lines, H alpha and H beta, that occur at two different wavelengths, and this belongs to red color, and this occurring at lower wavelength means higher energy, it belongs to blue green color, this belongs to red color. And these are for metal, sodium, potassium and magnesium, three lines, sodium, potassium and magnesium, that can be detected even by AAS as well. Here I am showing you an ICP spectrum of plutonium sample, means a radioactive sample. These all are plutonium sample, but from here you can see that the peak, this green peak and blue, this green peak and black peak, the A16 and A30, they are quite smooth, which shows that the sample is not disintegrated, while in this case A18 and A32, here you can see various peaks and various shoulder peaks. This shows the sample is being disintegrated, and because of this disintegration of the sample, because of the emission of those alpha beta particle, these lines have been disturbed. So these A16 and A30 means the sample is in good state, while in case of A18 and A32, the red color and the blue color, we are having some shoulder peaks, which means that we are having multiple peaks and some shoulder peaks as well, which means that the sample has been disintegrated. This spectrum present the extent of potential interferences. You can see that in case of A16 and A30, the black and green color, the spectra are smooth, so there are very low interferences, while in case of A18 and A32, the red and blue color, we have several peaks and some shoulder peaks are also there. This shows that we have interferences in this particular, especially the interference from uranium. So here the same has been mentioned that in case of plutonium it is being presented A18, A32 had deteriorated peak because of interferences, and some interferences occur because of uranium, while in case of A16 and A30 we have clean peak, we have very low or no spectral interferences. So with this I am sure you have got an idea about the spectrum of AES and AES and how we can make the analysis. As I just mentioned, focus on x-axis to know the type of element by comparing with the data available in literature, or if it is not available, do a standard sample run and compare if the peak matches with the standard, the sample belongs to that particular standard, while peak height or peak area on the y-axis gives you the concentration of the sample. With this, I hope you have completely understood the atomic emission spectrum, atomic absorption spectrum, and the ICP, which is used as an excitation source for atomic emission spectrum. In the next week, I'll start the second unit, which is related to molecular photoluminescence phenomena, in which I am going to discuss about fluorescence and phosphorescence. Till then, take care. Thank you very much.